Well, hello, and welcome to day one of module 3, which is all about congruent triangles. So let's do a quick review of angle measures because triangles are just basically three angles put together. So the first thing you got to remember is an acute angle is going to look something like this. It's less than 90 degrees, so we'll say this is 36 degrees. A right angle, remember, is 90 degrees. And then an obtuse angle, something that looks like this, we'll say it's 120 degrees, something greater than 90. If we wanted to find the perimeter of a triangle, so perimeter is the distance around, we would just simply add up the side lengths and equal it to 47. So 47 equals, and I'm just going to combine my like terms, that's 5, 6x, that's 14 plus 17. If you subtract 17 from both sides, you get 6x equals 30, divide by 6, so x is 5. You didn't have homework last night because we took the test, but, and then this is the video that you're watching if you're watching the video. All right, so let's look at our first exploration. What I'd like you to do is take your protractors out and measure each of these angles. This is angle A, B, and C. And then come back and see if you get the same measurements that I get. Okay, welcome back. Well, what I noticed was that angle A was 60 degrees, angle B was 60 degrees, and angle C was also 60 degrees. So what do we know about all three of these angles? Well, they're congruent. And there's another word for them. We also call them acute. And so this triangle, we actually call it acute. And because all the angles are equal, we also call it equilateral. Please check my spelling. It's terrible. And so all angles are congruent. Now, all the angles are going to be 60 degrees in a congruent triangle because if, we'll figure that out later, actually. I'm not going to tell you. It's a secret. What's also cool about a equilateral triangle is that each of these sides, if you measured them with your protractor, you would notice all three sides are exactly the same as well. So in an equilateral triangle, all angles and all sides are congruent. A second type of special triangle is this one right here. So once again, please pause the video. You go ahead and measure the three angles. We'll call this M, O, P. Go ahead and measure those three angles and then see if you come up with the same conclusions that I have. Okay, well, what I found is that M and P were both 70 degrees, or right around there, and then angle O is 40 degrees. And so what's cool about this is that this triangle has two equal angles, and if you noticed or you measured side MO, you should have gotten something around 3.25, 3.3, something like that. If you measured OP, you should have gotten something around the same thing, like 3.3. And then if you measure MP, you'll notice that it's like 2.4. It's way off. And so what else you can say is that the base angles are congruent, but so are those two side lines. So we mark those with tick marks. This triangle is called isosceles. And if you watch this video right here,
if you write anything on your computer, you need to get Grammarly.
I write pretty much all day, every day.
We really love triangles, said Euclid's friends, but we can't help noticing that they don't all look the same. Well spotted, said Euclid. The shape of a triangle depends on the length of its lines and the size of its angles. The most simple triangle has everything equal. Its sides and angles are all the same. We call this shape an equilateral triangle.
You actually made this on the very first day that we met.
Nodded their heads wisely. If we change the length of just one line, we now have two lines of equal length and two angles the same. This we call an isosceles triangle. Sausages? Euclid's friends gasped in disbelief. Isosceles, Euclid said very slowly. Isosceles. Euclid was really good at thinking up names for things, but some of his words were quite hard to say and even harder to spell. If all the sides of a triangle are different, then so must be all the angles. We call a triangle with different length sides a scalene triangle. A scalene triangle, Euclid's friends repeated. Is that it for triangles then? Not quite, said Euclid. There are three different types of scalene triangle. If all the angles in the triangle are acute, that is, that they are all smaller than 90 degrees, then it's called an acute triangle. Oh, cute, smiled Euclid's friends. You did that joke in episode 3, Euclid frowned, and it wasn't funny then. Sorry, Euclid's friends giggled. They still thought it was a really funny joke. If a triangle has one right angle, then it is called a right-angled triangle, said Euclid. Oh, right, Euclid's friends whooped. And finally, Euclid said firmly, a triangle with one obtuse angle, that is to say, an angle that is greater than 90 degrees, is called an obtuse angle, Euclid's friends cheered. Euclid smiled. I think you're finally getting the hang of all this geometry stuff. Well, what about squares? Euclid's friends asked. Are there different types of square? Well, sort of, said Euclid. But we'll talk about that next time. All this talk of sausages has made me hungry. Well, I hope.
All right, so that was kind of a cute little video there. Let's move on. Basically what you should have noticed is that we talked about all the different types of triangles, and now we're going to get into that vocabulary that matches. So you should have noticed that a triangle is formed by joining three non-collinear points. An equilateral triangle is one in which all three sides are congruent. An isosceles triangle is a triangle with at least two congruent sides. A scalene triangle, which is one with zero congruent sides, because all the sides are different. Now, an acute triangle is an angle whose largest angle is an acute angle. An equilateral triangle is in which all three angles are congruent and they all measure 60 degrees. A right triangle is a triangle whose largest angle is a 90 degree. And an obtuse is an obtuse angle, which is greater than 90 but less than 180. So another thing you need to know is that if you're looking at an internal or an interior and exterior angle, so I'm going to color these internal or interior angle here with dots, and then the external angle is here. So each triangle does have an exterior angle associated with it, but you'll notice that if you add an interior angle and an exterior angle, they add up to 180 degrees. They make a straight angle. Okay, so at this time, once again, you're going to pause the video, and the first thing you're going to do is you're going to go ahead and connect. You're going to use a straight edge. Each of these dots with a straight line. Go ahead and measure the side lengths and measure the angle. So pause the video at this point. Okay, welcome back. What you should have noticed is that, well, angle A, I got 100 degrees. And please note that I like to label my angles in the actual triangle. Here at angle B, I got 30 degrees. If yours is close, it's not going to be exact, but and this one here is 50 degrees, depending on your measuring skills. But if you do add all these up, you should have gotten a total of 180 degrees. And this brings us to another theorem, and this is true of all triangles, that the sum of the interior measures of all triangles is 180 degrees. And then in short form, this says triangle, sum of interior angles equals 180 degrees. So we've just shown that 3 angles in a triangle have a sum of 180, which is true going back to that 60, 60, 60. 60 times 3 is 180. And then we had a 70, 70, 40, I believe. 70, 70, 40 also adds up to 180 degrees. So all the triangles we've looked at today all have a measure of 180 degrees. This is kind of a cool proof. I have the link. I'm not going to show it in this video, but I do have the link in Canvas. So you can click on it and you can see why the sum of angles is 180 degrees. And basically what it has to do with is parallel lines. Do you remember this? If you have these 2 parallel lines, and then this would be transversal line number 1. Okay, and then this is transversal line number 2. What you can essentially show is that this angle right here and this angle right here are alternate interior angles, which means they're congruent. And you can also show that this angle here and this angle here are also alternate interior angles, which means they're congruent. And if you put all 3 of them on this straight line right here, you know that all 3 are going to add up to 180 degrees, thereby proving triangles add up to 180 degrees. Okay, what you'll need to do at this point is finish your packet and IXL F1 and F2. I've got some time here to do a couple example problems with you. So just remember, when you're finding the measure of each angle, we know that all 3 angles is going to equal 180. So then it's just a matter of combining your like terms. So x is going to equal 180 minus 90. So x equals 60. I'm sorry, not 60. 90. Ooh, it's a 90-degree angle. Okay, so all the rest of these are going to set up like that. Let's do another example. This one here, again, now we've got a variable, but 60 plus 70 plus x plus 58 is going to equal 180. So you combine your like terms. So x is going to equal 180 minus those 3 together, which is, I think, 188. So x is actually negative 8, which is fine. It can be negative. And then you're going to set up the rest of those like that. Here we go. We're going to be looking at equilateral and isosceles triangles. If you know this measure is 60, then you know this one has to be 60 because it's an equilateral. This one here, please note that the angles opposite the congruent sides are congruent. So if this one's 55, this one's also 55. Here we go again. So for this one, this side and this side are congruent. So that means we literally have to write this twice because it's 9x plus 8 plus 9x plus 8 plus 74 is going to give us 180. So be careful. This one would be another example of where you have to write 9x minus 2 twice plus 40 equals 80. But down here, these angles are the ones that are congruent. So you can just write x plus 70 equals 65 and solve it from there. Okay, and that should be enough examples to help you get through this. Here you're just drawing pictures and trying to solve the problem here. So hopefully this was helpful. If you need any extra help, go back and watch the video again. And don't forget to do IXL as well.